Everybody, you hear me? Wow, exciting prizes. So, I want to thank the Angular folks for having me here to talk to you. I'm going to talk to you today about a library called Falcor. Now, every user out there wants to believe that all of the data out there in the cloud is on their device, right? I mean, if you think about it, that's kind of what our job as web developers is to do. I mean, it's like 80% of our job. It's kind of like a conjuring trick, right? They request data, we go and get it from the network, we make it feel to them like it's sitting right there. But what if you could code that way? What if you could code as if all the data out there on the network was sitting right there on the device, and you didn't have to worry about the network at all? My name is Jafar Husain. I'm Netflix's cross-team tech UI lead. I'm the architect of Falcor, and I want you guys to ask yourself a question. I want us to do a little soul-searching together today. And that is, does MVC really separate concerns? Now, I know I look out and I see a lot of Angular developers out there, and there's a lot of MVC users, no doubt. Let's take a look at an ideal look of how MVC is supposed to work. I've got a controller, and it's responsible for marshaling the model from the cloud and handing it to the view. And the view can act like sort of like a black box and then take that model and output HTML. That's ideal, right? In sort of a unidirectional flow. Does it really work out like that, though? Let's see. Let's actually test it out. Let's see how we would work this into Netflix. Now, how many Netflix customers we got out there, people? Yes. I saw one guy in the back who didn't put his hands up, so I'm just going to explain to you how Netflix works. We are a video service, and we personalize recommendations to you. And so you can go ahead and select a title like House of Cards, for example, and then you can choose to watch it, or you can pivot to related titles and check them out. So if you were to sort of visualize Netflix's domain model, it's like a big graph out there. A big graph in the cloud with a bunch of titles that are all related to each other through that graph, right? House of Cards could be related to Breaking Bad, which is related to Jim Jeffries, which is related back to House of Cards, etc. So now, let's try and see what it would look like to use an MVC style, that same MVC style we talked about earlier, to do, say, a movie detail page. So let's say we select House of Cards, and we create a show detail controller and a show detail view. And that show detail controller makes a request for detailed information about House of Cards. And now, we grab that node in the graph, the House of Cards node, and we've got a problem all of a sudden. How much of the House of Cards title should the controller request? Should it get the name? Maybe the description? The list of episodes? The list of seasons? How does it know? In fact, there's really no way for the controller to know exactly how much of this graph it should grab. The fact is, the controller wants to grab as little as possible, right? It's more efficient if it grabs just the data it needs and sends it over the wire. The only way to know, though, what the minimum amount of data we can grab from the cloud is what the view uses. So if we take a look at this template, and the controller knows what the view is going to use, well, it's pretty obvious. We can just grab these 4 fields, and the service can execute a SQL query, grab just those 4 fields, and send down the minimum amount of data to the view. Now, this works, and it's really efficient, but it's not what I'd call decoupled. Just to prove that this really isn't very decoupled at all, and there's no real separation between the controller and the view here, let's imagine a PM comes by my desk, which happens every now and then, and they're like, you know what? House of Cards has got such a great cast, we really want to highlight it. So let's add a new field in the view talking about the cast of House of Cards. What do I have to change to make that happen? Well, obviously, I have to add it to the view, right? But realistically, it's not just a matter of changing the view and walking away. I need to go to the service that actually marshals this data, and I need to request an extra field. What does this view controller separation bot me? It's 2 boxes where I put code, but are they really decoupled? So let's say I select this data, we render it, we've got that field down there. That's great. But I suggest to you that the view is actually coupled to the controller, because the view depends on the controller to retrieve all the information that view is going to display. How do we decouple these things? How do we do better? I mean, do I just not get it, guys? Am I doing it all wrong? Well, I find typically when you ask a lot of developers, maybe 5 developers, what MVC is, you'll often get 4 or 5 different answers. But as far as I can see, this is a real problem, and it's a problem that exists in a lot of Angular apps. So why don't we try it a little differently? I can think of a solution to this. I'm not necessarily proposing you try it at home, but that is that we go and download. We just create a JSON resource for like all the data about a Netflix member. That's all the Netflix titles and their ratings, and we just download all the data right at the start. Now we've got all the data locally, And now it's a much easier problem. The controller decides what the root node is that it wants to hand to the gallery view, for in this case. And the gallery view just traverses and grabs as much of the data as it wants to. Right? It's just a JSON object in memory. No problem. Now I look at a movie detail page, exactly the same thing. Controller chooses what the root node is. View expands and traverses as much of the graph as it needs to display its information, and we get a detail page. Related titles, same thing. Everything's really easy when you don't have a cloud. Everything's really easy when the data's in memory, and it's easy to separate our concerns. Well, I don't think that's really going to work for most of us. Even if we could fit all that data on our device, we probably don't want to sit around and wait for 20 minutes while we download it all over a 3G connection. So that's where Falcor comes in. Falcor is an asynchronous model. It's a library to help you build an asynchronous model for your MVC. So what does that look like? Well, it allows you to kind of pretend that we did download all the data from the cloud. So we've still got our one HTTP resource, which has all the JSON data for this Netflix member. And instead of download it, we're going to have to virtualize it. We're going to create an asynchronous model which doesn't really have the data, but it's going to take any requests for information, and it's going to forward along to the service. It's almost as if we took the service layer and the model and we fused them together. So we request some data, a view requests some data. We actually use the query string to request just a fragment of that JSON, and we send it down. Now the view is driving. As long as the view is comfortable with receiving the data asynchronously, the view can describe exactly how much of the graph it wants to traverse, and then the model can go and get it. And so we go to a different page, the view starts driving again. It says, hey, look, I want this data. We send it down. And we go to related titles. Again, it's the view deciding how much of the graph gets traversed. And interestingly enough, we cache. That's an index figure, by the way. If we hit back, you hit the cache part of the model. We're transparently caching this model for you. It's still asynchronous, but we take it out of memory and we push it to you immediately. And so we go back, and that's completely transparent. We're caching it just like a web browser would cache resources that it previously encountered. How do we access it? The data. The data is the API. This is a big JSON document, a proxy for a big JSON document in the cloud. How would I load, say, the address from a person object in JSON? Well, I would just use a path. In a Falcor JSON model, I can refer to a JSON object out there in the cloud, and I can use the exact same API to retrieve the result. The only difference is that what comes out is a promise. So this allows us to do a pattern which I call asynchronous MVC. What do I mean by asynchronous MVC? Well, an asynchronous model. What we're doing is we're actually taking the last piece of MVC that wasn't async, and we're making it async. And we're seeing how that can actually give us the promise of MVC, give us the decoupling that we've always kind of been promised from MVC. So let's see, again, let's take a look at how that idyllic kind of MVC is supposed to work, kind of I think how most of the folks out there are doing it. And we know that introduces an implicit coupling, right? Because we're counting on the controller to retrieve enough of the graph so that when the view tries to display it, it's there. Well, here's what async MVC looks like. We create an asynchronous model, and the controller chooses the root node of that asynchronous model and describes that to the view by creating a new little asynchronous model that's just a little object in memory that's holding on to that path in the model. The view requests data from there. It might make several requests through a template, for example, a bunch of different fields. But because it's asynchronous, we can take all those requests and we can schedule them in one request to the server. And the requested data comes back. Notice now, it's not the controller making the decision about how much data out there in the cloud we download. It's actually the view driving it. And so we've totally decoupled the controller and the view. The controller's job is to choose the root node in the graph, and the view's job is to traverse as much as it likes. Maybe today the House of Cards shows the list of episodes, and tomorrow it shows the first 3 related titles. It can go as deep through the graph as it wants to. So what does it look like to create this root? What does it look like when the controller picks this little root object out and hands it to the view? Well, this is what it would look like in traditional MVC, right? I might call this service get genre list title by index, and that will give me, it'll have to choose some amount of that title to download, right? And I'm going to make this my property of my controller, and then the view can take a look at it. Asynchronous MVC, though, essentially we're using this bind method. Don't confuse this with template binding, but we're using this bind method, and we're creating this little other asynchronous model. It's just a little object in memory that's referring to that path, genre list 2.1. Now, title in this is still an asynchronous model. So we're creating this little asynchronous model that points to the right node. So in Angular 2, one of the things that's most exciting to me is that they are now going to allow you to bind to asynchronous data sources declaratively directly in your template. It's basically because the template syntax, as Misko just showed you, is so flexible that you're able to go from this, which is binding to a synchronous JSON object in memory, to binding to something that returns back promises. We need to add a little bit of extra stuff here, and what I'm doing here is I'm actually extending how templates work, and Victor's done some work to prove this out. And we can actually bind directly to things like promises or observables. By the way, who's heard of observables? Hands up. Quite a few people. OK. In fact, this framework will output observables as well as promises. And so you can bind either in the template. So now let's go back to the problem we had. I want to display a field. What does it take to make that happen? Well, our show detail controller, we're going to use our virtual model. It's going to say, hey, this is the root node. It's going to create this little virtual model proxy here. And the show detail view is going to request the data, but it's going to use a template. And the template is just going to list all the fields that it wants, declaratively. That's going to cause a bunch of different requests to go to this async model. But the async model is going to schedule all of them to happen on the next turn, and it's going to batch them all up. And so we get a request to the member JSON for all of the data that's necessary. Now I want you to look at the path that goes in here. What's actually happened when we bind, when we saw that bind expression earlier, we will automatically optimize into IDs for you. We have a graph format for JSON, because the challenge about taking all your domain model and putting it into JSON, JSON's not for graphs, and everybody's got a domain model that's a graph, everybody. And so we don't want to blow it out and create duplicates, but we do have to express it as a JSON object. And so I don't have time to talk about it today, but we have an encoding format for expressing your domain model as a graph inside that JSON that allows Falcor to learn about IDs for you. One of the most painful things, when you start working with remote data instead of local data, you need to think about IDs. I mean, imagine we did that thing where we downloaded all the JSON onto the device right to start. Would you ever think about IDs ever again? No, it's cheap to just traverse pointer references. But when you start working with remote data, you need to use IDs whenever you go back to the server if you have an ID, because it means we can make much, much more efficient back-end queries for things. And so Falcor makes this process transparent. Really, that's part of how it delivers on the promise of making remote data feel like it's local by automatically doing ID translations for you. And so it's requesting all of the fields in the template in one query and by ID. So we return the requested data. We output the HTML with the views in control, and it's driving how much of the graph it wants to traverse. And finally, we get House of Cards with that extra field. So Falcor is really based on three-dimensional freedom. It's the what, when, where of data. So what is our job? What is the actual data that we want to display to the user? We want to be able to describe what data it is that we want. And so I can create a Falcor model that refers to a JSON file out there in the cloud, and then I can pull out a path. What comes out is a promise. So if I run this, you'll notice on the right-hand side, we sort of selected TV shows. That's actually coming from the JSON object out there in the cloud, just visually representing it. But we can also grab a lot of data using this syntax that looks a little bit like CoffeeScript, but basically what we're doing there is grabbing a bunch of different paths, but we're doing it in a nice coarse-grained interface, which makes it very efficient. So if I run this, we get back the fragment of the JSON document out there in the cloud. So you don't need to pick arbitrary services anymore that carve out these arbitrary pieces of the cloud. You can just, on the client, request exactly what you want and no more. And you don't have to create all these different services either. And that's one of the real problems that we had at Netflix 3 years ago. We had this proliferation of services, and all of them return some subset of that data out there in the cloud, our conceptual domain model. And the problem was because they all returned some subset, some of them were overlapping, and that made it really difficult to cache. How many folks out there are actually caching in memory their own objects? They've got to keep an in-memory cache for the single-page web applications. Quite a few folks. Easy? Good. Somebody said yes. That's great. I'm glad. It wasn't so easy for us. Definitely not. Cache invalidation. Anybody ever heard that saying? There's only two hard problems in computer science. Naming things and cache invalidation? Yeah. This essentially keeps your cache coherent for you because you ask for individual fields. You're not going to go in and ask for an entire title object. You're going to be very specific, just like you would be about an in-memory JSON object, and ask for the specific fields that you want. And so you never have any overlapping messages from the server. It all goes down to these individual fields, and we keep a cache that's totally consistent for you. So you don't even have to think about caching. It just happens like when you use a web browser. So we have total flexibility about what data we request. We can make a single request and grab the entire graph if that's what we want. We now also have flexibility about when the data can arrive. So I can also use this particular, I can request this as path values, and now we're going to return an observable. And we're actually going to have the data stream back to us as quickly as it becomes available. Maybe it's coming over a WebSocket, maybe some of it's already in cache and it'll be pushed to us immediately, but eventually we can just have that data stream to us over time. And so we have all this flexibility along the when axis. Finally, and this is the most important thing, where is the data? You get to code the same way, regardless of whether that data is in cache, in a fast in-memory cache, or it's out there on the cloud. So how does this look? Well, I've got a JSON object, regular old JSON, nothing to see here. I can take that JSON data and I can load it into a local Falcor cache, into a model for a Falcor cache. So I've taken the same JSON object, I put it in there, and when I request it, this time I'm going to use an asynchronous API. And when I do that, I can load the exact same data. But now that I'm actually interacting with my data through a Falcor model and not directly through JSON, I have the flexibility to take that data and move it out into the cloud. On a node server, for example. So let's say, for the sake of argument, just temporarily here, you're actually okay with storing all your memory all your data in memory on a node server. Just for the time being, right? Probably not a good idea, don't try this. But this is effectively what it looks like. I would make a request, the HTTP source basically just sends this. It sends a path as part of the query string off to the server, and we run the exact same query on the model on the server, and we take the data and then we send it back. Now, it actually gets added to the client Falcor model's local cache. Now, as I said earlier, you probably don't want to store all your data in memory on a node server, right? I think those things go down pretty frequently, actually. So you should probably try and see if you can store it in data stores. That's where we like to keep our data, right? In databases. Sometimes not 1 or 2 or 3, but in Netflix's case, we've got like 80 services and a huge number of different databases. How do I take all that complexity and abstract it into something as simple as a JSON object? Well, it works exactly the same as your router in Angular, or a dynamic web server router in Express MVC, for example. You build routes through the JSON document, and you match them. And on demand, you go off to data stores and return that fragment of JSON. So what have we accomplished by doing this? It's almost like building a little web server into one HTTP resource. Why would we do that when we already have a dynamic web server? Well, it's to give us the flexibility to make a single request and retrieve a large amount of information. One of the problems about HTTP is that modern browsers can't necessarily make unlimited HTTP requests. It's really expensive to make HTTP requests, and sometimes if you're downloading little things like JSON objects, the actual cost, like the size of the HTTP headers, could be larger than the data that you get. And that's because something's changed in the last 10 years. The web has no longer become a place where you just go to get things, like Yahoo and news groups. It's become a place where we go to do things. We have web applications, and the difference between web applications and web pages is web pages have large resources, like images and documents. And web applications deal in large numbers of small resources, like JSON objects. And creating a separate HTTP request, which was designed for these coarse-grained objects, for every single little JSON object is just not practical. And so by putting all of the graph in one HTTP resource, we get around this restriction. So I can take another part of my document and retrieve it from a totally different data store there. So it's working just like a dynamic web server, where we realize HTML on demand based on a path pattern. Here, based on a pattern through the JSON document, we realize the fragment of JSON on demand. So today, in Netflix, everything uses Falcor. All of our apps essentially think of the cloud as a big JSON object in memory. And we're really excited about what Angular is doing to provide better integration inside of templates for asynchronous programming. This is something we'd like to see across all MVC frameworks, and we're starting to slowly see that happen. I think what it's going to allow us to do is really declaratively write a lot of the code that we write manually today, and basically bind your templates directly to the cloud and not worry about so much of that marshalling data and then handing it to a template, because the reality is you end up either overfetching or underfetching. And why not just have the view drive exactly the data that you display? So we're open sourcing this soon. We were hoping to get it ready for ng-conf, but we didn't quite get there. But we want it to be available in the next few months, certainly. And we're looking for help integrating with Angular 2. There's some really exciting things we could do by template integration with this, not just by allowing you to bind directly to the model in a template, but also by allowing you to parse through the template and look ahead and actually do predictive data loading. So if you want to check it out, Falcor.js is a Twitter handle, and that's my handle as well if you want to follow me and learn more about Falcor. And thanks very much.